Well, hello everyone and welcome back. We have reached a really exciting time in the course in that we have finished our complete study of derivatives and we are moving on to the final third of the course of new curriculum, and that is the concept of integration. So we're going to spend the rest of the course talking about integrals and their applications, what it means to integrate something, and we're going to get started on that today. So here we go. Okay, so let's start off with the definition of integration. Integration is the process of finding the antiderivative. Integration is the reverse of differentiation. So it's really important to understand that if we think of the derivative as moving forward, the integral is moving backwards. And if we know anti here, antiderivative, it is the opposite of the derivative, so it's going to move you in the opposite direction. Okay, you also see this phrase indefinite integral. We're going to talk about two different kinds of integrals, indefinite and definite. So everything that we focus in on this video today is considered an indefinite integral. Indefinite because there is not a definite numeric answer. When we get into definite integrals, we will have a numeric answer. All right, so this is the symbol right here for integration, and you're going to see that symbol a lot. All right, that is the symbol for integration. The differential, usually dx, dy, d theta, or dt, indicates the variable of the integral. So kind of like when we take the derivative with respect to x, we say dy dx. Now when we're doing integration, we take the integral and we also have to indicate the variable of the integral. So for example, if I'm taking the integral of 2x squared, afterwards I would say dx. If I'm taking the integral of sine of theta, afterwards I would say d theta. If I'm taking the integral of 3y squared minus 2y plus 1 over y to the third, all dy. And so what you'll notice here is that you have a variable at the end, that d variable. That variable tells you the variable of the integral. If they don't match, then you cannot take the integral. Okay, so it's time to learn how to actually take the integral of a function. The way that you do that is you follow these basic integration rules. And so we're going to go through 4 of them, and we're going to practice over and over until we get this down. Okay, so first of all, the integral of k dx is equal to kx plus c. Now k here is a constant. Okay, so that's important. K is a constant. And the way I know that is because otherwise I wouldn't have been able to do the integral of this because x and k don't match. So k is a constant, and if I'm taking its integral, it's simply kx plus c. Now c is another constant, and let's talk about where that comes from. Well, if you just kind of think about it, we said the process of integration is going backwards. So really, the process of integration is saying, what would I have had to take the derivative of in order to give me back 5? So hopefully you're kind of thinking about this and you're saying, the derivative of what is equal to 5? Oh, well, the derivative of 5x is equal to 5. But I hope you'll also agree with me that 5x plus 3 is also 5, and as well as 5x minus 7, as well as 5x plus pi squared. All of those, when you take the derivative, you get back 5. So when I'm doing the integral of a single constant, its answer is going to be the constant times x, whatever the variable is of integration. Now, the way that we show that in fact we don't know what this is here, we don't know what our constant is, we go ahead and say our answer is 5x plus c. This is considered general. Okay, we don't know what that c is, so in general it could be anything. The derivative of 5x plus any constant will give us back an answer of 5, which is why the integral of 5 dx is equal to 5x plus c. So 5x plus c is your answer. All right, now let's take a look at the next rule. What if I have a power? This is the one we're going to deal with over and over and over again. If you have a power, x to the n, dx, how do I do that? Well, let's just take a step back for a second. And what if I asked you to figure out what is the integral of 5x to the fourth? Well, dx. Again, if you're asking yourself, the derivative of what would give me back 5x to the fourth, hopefully you all would be telling me, oh, x to the fifth, right? Think about it. The derivative of x to the fifth is, in fact, 5x to the fourth. Okay, well, yeah, this one was pretty easy, and it was pretty easy to follow and think through that. But it's not always going to be that easy to think through. And so, if I look at this example here, what this is telling me, okay, the integral of x to the n dx, it's saying x to the, take your exponent and add 1, divided by the exponent plus 1. And then again, there's that plus c for the general solution. Okay, so if I were doing the integral of x to the fourth dx, I would keep my x, raise my exponent by 1, divided by 4 plus 1 is 5, plus c. Now that's one way to write it. Of course, we could pull that 5 out and make it 1/5 x to the fifth plus c. Either one of those answers are perfectly acceptable, and I hope that you would agree that if you were to take the derivative of this, you would in fact get back x to the fourth. Okay, a couple more rules for us to take a look at. The first one is the integral of k f of x dx. And you can see that it's equal to k times the integral of f of x dx. Now, don't confuse this with the first constant rule. This is when you have a constant times a function. For example, 2x squared. Okay? If you have something like that, you can pull the 2 out in front and just take the integral of the function in terms of x. Okay, so if you look at this first example that we have right now, let's go ahead and do that. So this is saying the integral of negative 2x cubed dx. So this rule tells me I can take the negative 2 and put it out front, and now just do the integral of x to the third dx. So negative 2 times, all right, this is going to be x to the fourth following my second rule, divided by 3 plus 1 is 4, plus c. Always have to remember that plus c. All right, now this is negative 2, think of it as over 1, 4. So negative 2 fourths, or negative 1/2 x to the fourth plus c. And that's your answer for that one. Okay, the next rule is an addition or subtraction rule for integration. And basically it's saying if you're taking the integral of the sum or the difference of two functions in terms of x, it's just simply that we're allowed to split them. So you kind of call this the splitter rule. Okay, you are allowed to split them up and take the integral of each one independently, and it just becomes the sum of all of them. So, for example here, if you're doing the integral of x to the fifth plus x dx, well, all this rule is telling me is that I can take the integral of x to the fifth dx plus the integral of x dx. And so my answer would be x to the sixth divided by 6 plus x squared divided by 2, and then your plus c at the very end. And so that is our answer. Okay, let's go ahead and work through these next few problems one at a time. So the first one asks for the integral of 1 over x cubed dx. Okay, just like with derivatives, it is a very good idea to first of all rewrite. All right, so we're going to go ahead and rewrite this as the integral of x to the negative 3 dx. And then we're going to go ahead and follow our rule. So that would be x to the negative 3 plus 1 would be negative 2 over negative 2 plus c. So that's our answer. All right, the next one, the integral of 5 square root of x dx. So again, I'm going to rewrite this. I'm going to put the 5 out in front, the integral of x to the 1/2 dx. So the 5 just comes down, and then the integral of x to the 1/2 would be x to the 1/2 plus 1 would be 3/2 divided by 3/2 plus c. All right, we definitely want to clean this up. And so if we are dividing by a fraction, remember that's the same as multiplying by the reciprocal. So this is the same as 5 times 2/3 x to the 3/2 plus c, which of course would be 10/3. And then you could rewrite this without the fraction. You would have the square root of x cubed plus c. Okay, number 5 here is the integral of x squared plus 1 all squared dx. Okay, now unlike the derivative rules where there's the chain rule and there's the product rule and there's the quotient rule, there are no such rules for integration. The rules that we are going to use we've already shared with you. And so if you have something like this, we definitely need to rewrite, and in fact we're going to have to FOIL. So we have to rewrite this as the integral of x to the 4th plus 2x squared plus 1 all dx. And now we can go and take the integral of each of these pieces. So the integral of x to the 4th would be x to the 5th over 5 plus 2. Integral of x squared is x to the 3rd over 3 plus, okay, the integral of 1, we're going to go back to our very first rule because 1 is a constant. So remember when we did the integral of a constant, we keep the constant and then we have x times x and then plus c. So that is our answer for our integral there. Okay, we're going to go ahead and practice a few more of these just to get more and more confident in our integration rules. Okay, number 6, the integral of x plus 5 divided by the square root of x dx. So again, we have to use our rewriting skills first before we try and do anything. So the first thing I'm going to do is rewrite this as x plus 5 divided by x to the 1/2 dx. Then I'm going to go ahead and break this. Remember, if you have a polynomial divided by a monomial, it's the same as dividing that monomial into each term of the polynomial. So it's the integral of x divided by x to the 1/2 plus 5 divided by x to the 1/2. And then, of course, your dx. All right, so now using our splitter rules, we know we can take the integral of each of these, but I'm not really done rewriting this yet, okay, because I want to get rid of those fractions. We can't have an x on the top and the bottom. So I'd rewrite this as the integral of, remember this is x to the 1 divided by x to the 1/2. Well, when I'm dividing powers, I'm going to subtract those exponents, so that would be x to the 1/2 plus 5 x to the negative 1/2, and of course dx. All right, so now I'm finally ready to take the integral. Okay, the integral of x to the 1/2 would be x to the 3/2 divided by 3/2 plus, keep the 5 out there, x to the negative 1/2 plus 1 would be 1/2 divided by 1/2 plus c. Okay, so now we want to just clean up those fractions in the denominator there. Remember, when you're dividing by a fraction, it's the same as multiplying by the reciprocal. So x to the 3/2 divided by 3/2 would be 2/3 x to the 3/2 plus 5 divided by a half is the same as 5 times 2, so 10 x to the 1/2 and then plus c. So that is our integral solution for this problem here. Okay, taking a look at number 7, the integral of 1 over 7x cubed plus the cubed root of x squared dx. Okay, so again, take a second to rewrite it. The integral of, this would be, here is your constant. So 1/7 x to the negative 3 plus x to the cubed root of x squared would be the exponent x to the 2/3, and then dx. Okay, so I've rewritten that, And now I have exponents that I can go ahead and take the integral. So the 1/7 is the constant that comes in front. And then the integral of x to the negative 3 would be x to the negative, add 1 to negative 3, negative 2, divided by negative 2. Okay, then the integral of x to the 2/3, well, I'd have plus x to the, all right, I'm adding a 1 to 2/3, which is like adding 3/3, which of course is going to give me x to the 5/3 divided by. Now, if you notice and you start to notice a pattern here, rather than writing dividing by 5/3 and then having to clean it up later, okay, rather than doing that, let's just go ahead and multiply times the flip right away. So 3/5 right in front. Okay, when you finally, when you get comfortable with that, it's going to make things a lot easier and it's going to clean up your steps a lot faster. Okay, so plus 3/5 x to the 5/3 plus c, of course, equals. All right, let's just clean up that first term a little bit more. So I'd have 1 over 7 times negative 2 is negative 14. And of course, x to the negative 2 would come down and make it over x squared, okay? And then plus, like we already cleaned this up, 3/5 x to the 5/3 plus c. All righty. Okay, last one of this type. Let's go ahead and again rewrite it. So I'm going to say the integral of, again, I have that polynomial divided by a monomial, so I'm going to divide that 5x squared into each of these terms. So I'm going to have x to the 3rd over 5x squared plus 2x squared over 5x squared minus 7 over 5x squared. And that's all dx. Okay, so now I'm going to take one more step to clean up the exponents. So the integral of, this would be x over 5 plus, here your x squareds are going to go ahead and cancel, and so I just have 2/5 minus, here I'm going to rewrite this as 7/5 x to the negative 2, and it's all dx. Okay, so what is my constant on that first term as I'm taking the integral? Well, think about it. X over 5 is the same as saying 1/5 x. So I'm going to bring down the 1/5 and then take the integral of x would be x squared divided by 2. Plus 2/5 is a constant term. So remember, the integral of a constant term is simply just 2/5 and then x. Minus, copy your 7/5, the integral of x to the negative 2, remember we're adding 1, so it'd be x to the negative 1 divided by negative 1, and then your plus c. All right, so definitely need to clean this up. This first term here would be x squared over 10 plus 2/5 x. Okay, then we have this negative here, and we were dividing by a negative 1. Well, of course, a negative times a negative is going to be a positive. So we have plus 7/5, and then our x to the negative 1 is going to drop down and join the 5 in the denominator. So 7 divided by 5x plus c. All right, and that is our integral solution. Okay, so now that we've begun to get the hang of taking the integral of a function, we're going to talk about finding a solution to a differential equation. So there's two different kinds of solutions that we're going to talk about. General solutions, which we're just briefly going to touch on, and really what we've been looking at all along have been general solutions. And then we're also going to talk about particular solutions. So what does this mean? To a differential equation. Don't let that throw you off. Differential equation, it kind of sounds scary, but this is a differential equation. Why? Because this is a derivative and it's an equation. So it's just saying f prime of x is equal to 1 over x squared. That's your differential equation. Well, if I wanted to go backwards to find the solution is just asking for the original function. What was the original function before you took the derivative? How do you go backwards from the derivative? You take the integral. That's what we just talked about. Those are the antiderivative is also called the integral. So I'm going to go ahead and take the antiderivative of the left-hand side of my equation to go from f prime of x to f of x. If I take it of one side, I have to balance my equation, and I'm going to take it of the other side. And so what happens here is the antiderivative of f prime is simply f of x equals, and now I take the antiderivative of 1 over x squared, which, of course, I need to rewrite first as x to the negative 2. And so now I say f of x is equal to x to the, add 1 to negative 2, and you get negative 1, divided by negative 1, or I'm just going to put a negative out front, plus c. Okay, and of course you could rewrite that one last time as negative 1 over x plus c. So that is my general solution, and it's general because of this plus c. Okay, what if I were asked the same question, but this time I'm asked for a particular solution, again to the same differential equation, but now I have to be given an initial condition. See, when you're given an initial condition, you are going to be able to solve for your c value. So you start this problem the exact same way. Okay, we do, like we just did before, the integral of f prime of x dx is equal to the integral, I'm going to rewrite it as x to the negative 2 dx. And of course, this is f of x is equal to negative 1 over x plus c. Well, now, this is where the initial condition comes in. They're telling you that that we know for sure that this point, 1, 0, is on the original graph of f. And so I should be able to take and replace my y value with 0 and replace my x value with 1. And now I can solve for c. So 0 is equal to negative 1 plus c. c is equal to 1. Now that I know my c value, I'm able to take it and plug it back in here so I have the actual particular solution. F of x is equal to negative 1 over x plus 1. That's the particular solution for this differential equation satisfying this initial condition. That is my answer. Okay, let's try another one like this. Find the particular solution to dy dx equals 3x squared minus 1 given the initial condition 2, 4. Okay, so first of all, don't let this throw you. This is just another way of saying, of course, the derivative of a function y is equal to 3x squared minus 1. And so same thing. Now, I'm just going to kind of shortcut. I know that if I took the integral of dy dx, I'm going to get y. Oops. I'm going to get y. And now that's equal to the integral of 3x squared minus 1 dx. So y is equal to, go ahead and take the integral of each of these pieces. So 3 times the integral of x squared would be x to the third over 3 minus 1 is a constant, so 1x, and then your plus c. Okay, obviously here your 3's are going to cancel, so we get y equals x to the third minus x plus c. All right, now it's time to bring in our initial condition of 2, 4. Obviously, that's a point, so x is 2, y is 4. So I'm going to plug in the 4 for y, and I'm going to plug in the 2 for x. So 2 cubed would be 8 minus 2 plus c. And I'm just solving this. 4 equals 6 plus c. c equals negative 2. So now that I have my c value and my general solution, I put the two of those together and I get y equals x to the third minus x minus 2 as my particular solution. Okay, last one of the night asks us to solve the differential equation with the given conditions. Now look at what's different about this one. Clearly, hopefully you recognize that we are given, in fact, the second derivative. And so if we want to go from the second derivative down to the original function, I'm going to have to do the integral, hopefully you realize, 2 times. The integral of f double prime would be f prime. The integral of f prime is f. And then if you notice, we have 2 different conditions, one for f prime and one for f. So let's work our way through this problem. Let's start by doing the integral of the second derivative is equal to x to the negative, the integral of x to the negative 4/5 dx. So this is going to be f prime of x is equal to, all right, we're going to have here x to the, if I add 5 over 5, I would have 1/5. Divided by 1/5 would be the same as multiplying by 5 plus c. Okay, so before we move on, we have to find out what that c value is for the f prime function. And of course, in order to do that, we're going to bring in our first condition, which was f prime of 1 is 8. So I'm going to plug in 8 equals 5 times 1 to the 1/5 plus c. So this is obviously 8 equals 5 plus c, so 3 is equal to c. All right, so now I know that f prime of x is equal to 5x to the 1/5 plus 3. Okay, so now let's go ahead and do the integral of f prime, which of course would be f of x is equal to, and we have to take the integral of the other side. So the integral of 5x to the 1/5 plus 3 dx. All right, so f of x is going to equal 5. Okay, now we're adding 5/5 again, so this would be x to the 6/5 divided by 6/5 is times 5/6 plus 3 is a constant, so 3x plus c. All right, so let's just clean this up for a second. I have f of x is equal to 25/6x to the 6/5 plus 3x plus c. All right, and the condition that I have here now that I need to bring in is that f of 0 is 3. And so I can go ahead and say that I have 3 is equal to 25 times 0 plus 3 times 0 plus c. So it's just going to equal my c. So again, for both the first and the second time, c is equal to 3. So I can now finally say that in fact, my function, the solution to this differential equation, is 25 over 6 x to the 6/5 plus 3x plus 3. Okay, this video has introduced you to what an integral is and the basic integration rules that we use in order to take the integral of a function. We also went ahead and talked about the difference between a general and a particular solution, and then how we went ahead and found a particular solution to a differential equation. So we've done a lot. I hope that you've taken down good notes and that you're ready for class next time. Thanks so much.